So today we're going to talk about the unit circle. And the first thing that we need to tell you about is the unit circle is split up into four quadrants. You got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay. In quadrant 1, the x and y would be positive, positive, just like it is in the regular coordinate plane. In quadrant 2, the x value is negative and the y value is positive. In quadrant 3, it would be negative, negative. And in quadrant 4, it would be positive, negative. All right, so the way the unit circle works is it typically goes, like we talked about, counterclockwise for positive, clockwise for negatives, right? And how it works is you got different triangles here. So this is a special right triangle. And it repeats itself in every single quadrant. Okay, so let's talk about that red triangle. So that red triangle is a 30, 60, 90 right triangle. Okay, the hypotenuse of all the triangles in the unit circle is always 1. That's the radius. The radius of the unit circle is 1 unit. Okay, let's refresh our memory. So in a regular 30, 60, 90 right triangle, remember the short side is always your x. The long side is always x times the square root of 3, and the hypotenuse is equal to 2x. So based on this information, we can actually figure out the rest of the units, the rest of the triangle here. Because we know that 1 is the same as 2x, which means when you divide by 2, x would be 1/2. Well, according to this, the 1/2 goes opposite 30, so it would go there. That's the shorter side. The longer side is x times the square root of 3. Well, you just found out that x is 1/2, so it's 1/2 times the square root of 3, or the same as square root of 3 over 2. And the reason why this is important is because it talks about this is how you get the ordered pairs. Okay, the base of the triangle is always your x value. The height of the triangle is always your y value. So if we go back to our unit circle, okay, the base of this triangle was 1/2. The height was square root of 3 over 2. Now this also helps us in recognizing trig functions. If we scroll down to the bottom here, sine is always the y value of a coordinate point of the ordered pair. So this would be your height of those triangles, right? Okay. Cosine would be the x value of those ordered pairs, which would be the base. And your tangent is always y divided by x. Okay. And what happens is this pattern actually repeats all the way around. So it's 1/2 square root of 3 over 2 on this triangle, 1/2 square root of 3 over 2 on this triangle, and 1/2 square root of 3 over 2 on this triangle. The only thing that changes is the positive and negative. So we talked about in quadrant 2, the x value is negative. Okay. In quadrant 3, both the x and the y are negative, and in quadrant 4, the y is negative. So now you have all of those ordered pairs. Then you have another triangle that takes place in these, and it's another special right triangle. Okay, and in this one, and all these green triangles, these are all 45, 45, 90 right triangles. So 45, 45, 90. And again, we know the radius of that is 1. Okay. Remember, in a 45, 45, 90 right triangle, in a regular one, okay, you have the sides be the same length, and the hypotenuse is x times the square root of 2. Well, knowing that information, we know that this will be 1 equals x times the square root of 2. But to find x, that means you have to divide by the square root of 2. And as we learned in the rational functions, you cannot have a square root in the denominator, so you got to multiply by the square root of 2. So what you end up getting is x to the square root of 2 over 2. And that's going to be your height and your base. Well, in the unit circle, we learned that the base is x, so it's square root of 2 over 2. And the height is y, which is also square root of 2 over 2. And like I said, it repeats all the way around. The only difference is your signs change. So in this one, the x is negative. In this one, they're both negative. And on this one, and you notice you can see the degrees there, okay? The y is negative. Okay? Then you have one last triangle that exists, and that's this one. And these are also 30, 60, 90 right triangles. Okay, so let's go to it. But this time the 60 is in the bottom and the 30 is in the top. Again, the hypotenuse is 1. So if we redraw this time x would be the base, 2x is your hypotenuse, and x squared root 3 is your height. So again, same thing. 1 is equal to 2x. That's your hypotenuse, so we're going to equal that. So x is 1/2, which in this case is going to be your base. And your height in this case would be square root 3 over 2. And I realize I just screwed up your order pairs here. This should actually be, let me erase this, reversed, because x was square root 3 over 2. So this needs to go away. This needs to go away. And this needs to go away. So let me redo those. Okay, so this was square root of 3 over 2, 1/2, both negative. This is square root of 3 over 2, 1/2, y negative. This is square root of 3 over 2, 1/2. And this is square root of 3 over 2, 1/2 with the x negative. And then in this one, the base was 1/2. And again, your signs change as they go around. So the x is negative in that one. They're both negative in this one. And the y is negative in this one. Then there's a couple other ordered pairs that you got to deal with. Okay. For this one, this is at 1, 0. This one's at 0, 1. 180 is at negative 1, 0. And then this is at 0, negative 1. Okay, so that is those. Okay, now I'm going to also provide you the radian measures, and just a quick refresher on radian measures. Let's take 30. Okay, so 30 degrees, to find the radian measures, you multiply by pi over 180. That means that you get 30 pi over 180. Drop the zeros, so that's 3 pi over 180, both are over 18, which means that it is pi over 6. So the radian measures of 30 degrees is pi over 6. Okay. For 45, same thing. Multiply by pi over 180. And actually, I think, yep, it's divisible by 45, so it's pi over 4. So 45 is the same as pi over 4. And then 60 would be 60 pi over 180, which is 6 pi over 18, which reduces to pi over 3. 60 is pi over 3. And I'll give you the rest of them all the way around. 90 is pi over 2. 120 is 2 pi over 3. 135 is 3 pi over 4. 150 is 5 pi over 6. 180 is just pi itself. 210 is 7 pi over 6. 225 is 5 pi over 4. And this is 4 pi over 3 at 240. At 270, it's 3 pi over 2. At 300, it is 5 pi over 3. At 315, it's 7 pi over 4. At 330 is 11 pi over 6. And then at 360, that is 2 pi. So 0 on this side of it and 2 pi on the bottom side of it. Okay, so a quick refresh on the signs. Okay, so remember everything is positive in quadrant 1. In quadrant 2, the y is positive, the x is negative, which means tangent is negative. In quadrant 3, the sine and cosine are both negative, but that means the tangent is positive. And in quadrant 4, the sine is negative, the cosine is positive, which means that your tangent is negative. All right, let's go ahead and do some examples, and let me go ahead and move this so that we can split screen it so I can show you what's going on. All right, so here's how it's going to look. They're going to give you, like, they're going to tell you to find the sine of 150. Well, if we go to our unit circle, 150 degrees is right here. Sine is representing the y value. So the y value of 150 would be 1/2. And that's it. Tangent's a little bit different. So first, for tangent, you need the x and the y. So the order pair is 1/2 negative square root 3 over 2. So now I'm going to make this a little bit bigger. Okay, and we're going to go to the next page. So tangent of theta is y divided by x. Now we just said the tangent of 300 was 1/2 negative square root 3 over 2. Well, if I do this y divided by x, it means I would have negative square root 3 over 2 divided by 1/2. Well, remember when we do this with fractions, right? Negative square root 3 over 2 stays the same, keep, change that to multiplication, flip the second fraction. So what happens is the 2's cancel out, and you're left with negative square root 3 over 1, which comes out as negative square root of 3. So this would be negative square root of 3. So if we go back, cosine at 225. So 225 right here, this line right here. Okay, cosine is the x value, so that would be negative square root of 2 over 2. Okay, for cotangent at 315. Okay, for cotangent at 315. So the ordered pair for cotangent at 315 is negative square root 2 over 2, or positive square root 2 over 2, negative square root 2 over 2. Well, if we do it, cotangent would be the reciprocal of tangent, which means it's actually going to be x divided by y. So if we take our x, which is square root 2 over 2, divided by negative square root 2 over 2. Okay, keep the first fraction the same, change that to multiplication, flip the second fraction. And what ends up happening is everything cancels out. We're left with just negative 1. Okay. And you just repeat that process all the way around. It repeats with the radians. It doesn't change anything. Just look at the radian measures, which are the insides of this unit circle that we've provided you. Okay. And if you have any questions, let me know.